Hello and welcome to Software Architecture course. Today we will talk about software structure and views. So in the last lecture we have introduced what is architecture views. In fact, view is a technique by which a complex description like software architecture can be represented in a multi-dimensional way. Each view is a dimension. So, and we said that it is required because otherwise architecture description becomes so complex. If one uses one single view to describe everything which is going to satisfy every stakeholder, then it becomes so complex that it becomes difficult to understand. So architecture is basically a set of views, and each view represents certain architectural aspects of the system which is specifically meant for a set of stakeholders. And when all the views are combined together, it forms the architecture. And we also said that a structure is essentially the underlying part of the view, essentially the set of elements and their properties, and view corresponding to a structure is created by using these elements and their interrelationships. So in a sense, view is something that's used to describe a particular architectural aspect, and view is something that is meant for a stakeholder which who can go through this view and understand, reason about it. A structure is a mechanism by which a view can be created. So question is that what sort of view, or what are the set of views that we want to use to describe architecture? What is best? Well, like the definition of architecture, there are many views that also exist today, but out of those we will basically choose the one which is most popular, and then that's actually integrated in a tool, and it is used quite universally. It's called Rational Unified Process Model, or Christian's 4+1 view. So Christian's 4+1 view has been integrated in the RUP, and UML uses this 4+1 notation to describe these views. So it makes sense to basically understand 4+1 view in detail. However, there are other views that exist, as I said. For example, Siemens Corporation has come up with architecture framework much before Christian's 4+1. So they propose that architecture should be described using conceptual view, module view, code view, and execution views. Then C4ISR framework is also there, which has got 3 views: operational, system, and technical. There are classical approach like data flow and control flow type of views. RMODP, suitable for distributed system development, which was proposed again much earlier than Christian's. It proposed 5 viewpoints. Now these 4 are essentially for you to understand and know that they are 4+1 is not the only view. There are many other views exist, but we are going to focus only on 4+1. So here, rather than talking about views, let us focus on the structures. And because the structure is a fundamental element that's going to enable the views, and views are something that, as I said again, architect should be creating those views. And but architect must know what the structure and how to use the structure to create a view. So we are going to create, we are going to learn 3 structures. One is called the module structure. So the purpose of the module structure is to describe how the system is to be designed as a set of functional units or modules. So purely a set of functional elements. Then the second structure is called the component and connector structure, and this particular structure is meant for describing the system when it runs, or a runtime view can be created using component and connector structures. Here a component means a computation unit at runtime, and a connector means the communication channel between the components, and it can model parallel execution. The last structure is essentially called allocation structure. It describes how the system related to other non-software structures in its environment. For example, how is the system going to be deployed in a cluster of CPUs, how the file systems will be used to store the data, what kind of network is going to be used to implement the communication channel, who are the development teams, and so on. So let us look at these structures in detail. We'll start with the module structure. Has got so the entities that we are going to deal with in this structure is module and the class, and the module could be decomposed. It can use certain other module. It can be decomposed into submodules. So the module structure essentially includes decomposition, uses relationship, layering relationship, and class or generalization relationship. Let's look at these things in detail. A decomposition means that a module can be decomposed into a set of submodules. So when you are using module structure and you are describing a view using this module structure, then oftentimes you will be using modules, submodules, a module consisting of submodules, and all the submodules here, the meaning is that all the submodules are combined together to form the higher level module. Uses uses relationship is used for reusing functionality of other modules. For example, a module can use the functionality of another module for its behavior. So module exposes certain functionality, and in order to implement its functionality, it might require help of other modules. So we say that a module is using other module to accomplish its behavior. Layered means that modules can be hierarchically organized, one on top of another. So in a given layer there could be a set of modules. If you recall the architecture diagram that I had shown for both Windows and for both Windows operating system as well as Android operating system, you would have seen that the modules are organized in layers. So the layering is basically an important element in the module structure, and the meaning is that layer n is using the service of layer n minus 1. In other words, if there is a module in layer n, it can use the service of the modules which are immediately below this particular layer. Now layering is also considered to be an important design architecture pattern, and we are going to learn that later on. But for now, let's focus on the structure. That layering is essentially an important structure, and then the last one is a class or generalization. So essentially module can consist of a set of classes, and this class is nothing but the class that you all know in the object-oriented concept. So it is the same thing. Let's look at the next structure called component and connector structure. So here you see the elements that are important are basically component and connector, and what are even more important in this component connector, essentially client server, concurrency, process, and shared data. Let's look at what are these. So using component and connector, we can actually model something like a client server. What does that mean is that when we want to represent a client server, then a component can be client or a component can be a server. So you can annotate, you can define a type of a component to be a client or a type of a component to be server. And then the connectors implement or connectors model how these components are interacting with each other. When we deal with concurrency, if you want to model concurrent executions, then essentially components model a unit of computation, and the connectors are logical threads of execution. So if there are multiple connectors, they implement multiple threads or they model multiple threads. That's how the concurrency can be used. Process or a communication or a communicating processes model, that can be for this to represent this, I can again use component and connector. So here components are processes and connectors actually describe how these processes are communicating with each other. Shared data or repository. Here the components model data store, and components can also model computation elements that accesses data store, and connectors describe how the data is created, stored, or retrieved. So this is actually this whole thing is quite simple. At the same time, it is quite powerful. Simple because in component and connector, all we are talking about is basically boxes and lines. Now you can interpret a box in any way you want. Now in component and connector structure, it is guiding you to basically interpret boxes as either client or a server or computation unit or processes or data store and so on. Similarly, connectors or the lines basically model how they interact, and you can basically provide more specific interaction. For example, in a client server, you can actually model the communication protocol, how they are interacting. In case of concurrency, that same line now represents a thread. For processes, it models inter-process communication. For the shared data, it models data access. So it can model different things. So the same line can represent different things. So the important part is that when you're using component and connector, you need to provide its attributes or properties, so that the component can model either a client or a server or a computation unit or a data store and so on. Similarly, you have to provide the appropriate attributes for connectors, so that a component connector based view becomes unambiguous. Let's look at allocation structure. So allocation structure essentially has three important aspects. One is deployment, then second is implementation, and third is work assignment. So deployment means that here it actually captures how units of software, which is essentially process from component connector, and units of hardware, which are processors. So the interesting thing is that here also, when you are describing a view using allocation structure, then also you are going to have boxes and lines only. So one type of boxes will be the boxes that you have defined in component connector, and another type of boxes will be hardware elements. And if you create a link between these two, this link implies a relationship, and that relationship is that how a software is allocated or migrated to a hardware. That's what will be the meaning. Implementation, here you could use elements from module structures, or a view that uses module structure, which is why I said module view. What it actually means is that when you create a view using the module structure, so whatever units that you have used in modules, these are software units. And in the allocation structure, the connectors or the link between these units, they model how they are mapped to files or folders. So you can have a module from module view or module structure view, and you have another set of boxes which can represent files and folders. And if you draw a line between these two, it actually implies that how a module is going to be mapped or implemented to a set of files or folders. Work assignment is, again, here the units are modules from module views, and the other type of units are essentially people. So a people can be represented as a unit, and then a link or a line implies that there is a responsibility for implementing and integrating the modules by these people. So if you draw a line between a people and a module, then it means that this person is going to implement or integrate this particular module. So what was said earlier, that allocation structure is essentially there to create a link between different types of entities, cross-referencing, linking, traceability. So allocation structure is used primarily for that. So the cross references are how the software processes modules are finally deployed onto hardware boxes. Implementation is how modules are mapped to different files or folders. So if you look at implementation and work assignment, you'll realize that how slowly architecture is now describing architecture is how how architecture is describing the translation of the architectural description to design. So earlier I said that there are stakeholders which are developers, team and team leads who are going to use architecture, and they are going to ask questions as to how I'm going to implement it. Now you are going to use allocation view or you're going to use allocation structure and define a proper view so that they are clear. So essentially what it is trying to say is that you could basically create an implementation view where you can define this module map to files, and this could be a guiding principle for the designers or developers to develop this software system. So let's look at these structures again, and let's look at what we have learned. So start with the module structure. We learned decomposition uses layered and class. Essentially decomposition is a relationship, which means it's a submodule. And why it is useful? It is useful for resource allocation, project structuring, information hiding, encapsulation, etc., and even for configuration control. Let's look at the another entity or another type of relation, which is basically using or usage relation. So users relation, it basically says that it requires the correct presence, And what it means is that um, one can basically do some analysis that whether for a particular module, if the particular module is trying to implement certain features, does it use or does it use the features of other modules, and for this particular module which is implementing a functionality, who are the other people, who are the other modules, sorry, who are not the people but who are the other modules who are going to use this functionality. So essentially, if I'm talking about a module M which is exposing a functionality, then the usage relationship will basically tell that what are the other modules on which this particular module M is dependent on to implement its functionality, and it will also tell what are the other modules that are going to use the functionality of M. So usage relationship is used for that. Layered relationship is basically, again, it helps in incremental development, and layering is a well-known way by which one can have a concept of virtual machine. It can implement the portability. We will learn about layering architecture, layering patterns actually later on in much more detail, which is why let us not spend much time here, but we will just understand that layering is basically a kind of relationship where a bunch of modules are grouped into a particular layer and layers are stacked, and the property is that a module in an upper layer can use the module of its immediate lower layer. So in a sense, layering is also imposing a constraint. Class is, again, it's a OO design system kind of concept. It produces implementation templates, and class is something that is used for the transition from architecture to design. So from module, if there are classes and if there are a relationship between modules and classes, it actually gives a clue to the developers that how these classes are linked to the modules and how it will be implemented. Let's look at the component and connector, which is going to model the runtime environment. Here, client server is essentially dealing with communications, and it is used to really model distributed operations, and it can do a separation of concern. One can do performance analysis, load balancing. All these analyses are possible if a client server kind of view is described in a formal way. Process view is again used, can be used for performance analysis. It can be used for scheduling analysis. It can actually model concurrency. It can model in terms of execution flow, which particular computation precedes which one, and so on. Concurrency is again if there are two components which are connected by a connector, then it means that they are running on the same logical thread. So it identifies locations where the resource contentions may exist. If a concurrency view is drawn, that view can be used to analyze certain characteristics like where the resource contention might exist, where the threads are going to fork or join, etc. So those analyses are possible. In the shared data, again, it can be useful for performance, data integrity, even modifiability. So the final one, which is allocation structure, for that development is primarily deployment structure is used primarily for performance, availability analysis, security analysis. Implementation is useful for configuration control, integration, testing activities. So these are primarily used for the more downstream development team, configuration management team, testing team. So for that, this implementation is used. Work assignment is used for project management, and best use of expertise. Then management of commonality that can exist across subgroups. So such kind of analysis are possible if the work assignment view or work assignment type of view is actually created. So here you have observed that I have kind of resisted myself not to speak about views but to speak about the structures, because a view is something that as an architect you have to define and create. Many a times it is perfectly acceptable if in your organization you define a set of views that are suitable for your development, but you use these structures. So but in reality, of course, in many of the organizations they really do not, or they are at least trying to move away from very custom specific views. They're focusing on more of a rational unified process, primarily for the sake of usage of tools and so on. But the idea is that one can use their own views as long as they use these three structures, which is why I did not speak about views. So here, for example, deployment, implementation, and work assignment can as well be created as three different views created out of allocation structure. So which structure to choose and what views to choose? Let us focus on 4+1 views. This has been institutionalized as RUP of architecture description. So 4+1 view essentially describes that there are 4 views: logical view, physical view, process view, and the development view. Let us look at what these views do. So the logical view is meant for the end users who are concerned with the functionality, and logical view is essentially linked to our module structure that we have learned. Let us look at physical view. Physical view is essentially our allocation structure, and it is meant for infrastructure team which are concerned with topology, communication, security, allocation, or deployment. People can also call it as deployment view. Sometimes people can call it as deployment view instead of physical view. Process view is meant for integrators, architect, concerned with performance scalability. Essentially, this is nothing but component and connector. And the development view is used by the development team, which are concerned with software management, and this is also allocation, and under allocation it is implementation and work assignment. Now if we are to stick with this 4+1, we talked about 4. What about the fifth one? The fifth one is the use case scenarios. Use case binds all the 4 views together and describes the behavior of the system in a semi-structured text. Now architecture is about structure as well as behavior. In this 4+1 view, the use cases are used for the behavioral description. Now if we stick to this 4+1 view that is proposed by Christian, and it is now a part of RUP, then you can readily get a lot of tools, UML tools, which are now coming out of IBM and many other open source free tools. Now those tools will give you these 4 views, and you can basically describe your own architecture using these notations. So whatever has been taught as a part of module structured allocation structure or component connector structure, those elements already exist or will be existing in the tool itself, so you can just use those to describe your architecture. So that's all for this lecture. In the next lecture we'll talk about quality attributes. Thanks.